Good afternoon, everyone. And good morning, everyone. I think
Good morning, ma'am.
I'm sorry for keeping everyone waiting. It was not intentional. So much on my head that I forgot that I have an appointment today. Apologies, tender. So let's enter into the class proper. We are on naming of organic compounds. Please let everybody be muted. Let everybody be muted.
Questions from section B.
Aruna Kamara. Aruna Kamara. Please be muted. Please let's mute ourselves. Is the rep around? First rep, is he around? Please put into your general platform that the class has started. Put it in the general. Where is the rep?
Yes, ma'am. I put it down already.
Okay.
Yes, I put it down already.
So rep, you're going to help me control the class. Make sure that everybody is muted so we don't get distracted. Thank you. Okay, we are talking about naming of organic compounds. I think we've talked about saturated organic compounds. We also talked about alkene. Okay. Now, who can remind us where we are in this naming? Or did we finish the naming? Did we finish the naming in the last class? Rep, represent your team. Did we finish the naming? No, we talked about alkene. Okay, we've not done alkyne. Okay, let's take some questions before we continue. Let's take some questions before we continue. If you know you have questions, respect to previous class, can you unmute yourself and ask your question as regarding nomenclature or the previous classes we had? So I'm waiting for your question before I continue. Any question? So no question. So let's continue. We talk about cis and trans for alkene. Okay, in this particular slide, if you can look at it, you realize that they highlighted in every of the carbon connected by a double bond, we have two substituents. So one is going to have higher priority because of higher molecular weight. So whenever we see 1 and 2, the 1 is the one that have higher priority. Okay, and remember when 1 on each of the carbon are on the same side, we say they are on cis. When that one is on adjacent or opposite each other, we say they are on trans. With the first compound, we can see that methyl and ethyl are 1-1. So each of the carbon 1 is methyl, while carbon 2 is ethyl as priority substituent. So because they are on adjacent carbon sides of the compound, we are going to say that this is trans isomer. And trans isomer is what we regard as E, while cis isomer is what we use SZ to represent. Okay? Okay, so that's all you need to know here. Then let's talk about alkyne. Alkyne is an unsaturated hydrocarbon, while alkane is double bond, alkyne is triple bond. So triple bond means that it has 1 sigma bond and 2 pi bonds, meaning every reaction that alkane will need 2 mole, alkyne is going to need 4 mole. Okay? Any reaction alkane is going to need 1 mole, alkyne is going to need 2 mole. So whatever alkane needs, alkyne is going to need double portion of that because of alkyne is highly unsaturated. Okay, remember when you are unsaturated means you can accept more. You are very, very hungry, you're very, very unsaturated. But when you are saturated, you can really eat because you are filled up. Okay, and when you want to force yourself. That's why you start seeing somebody vomiting, because the person was super saturated and want to force. There's no space. For there to anything to happen, you do what we call substitution reaction. You have to let go what you have before you add another one. So that's the essence of the vomiting. Okay, having said that, whenever you want to name alkyne, we have to consider the carbon that bears the triple bond, just like we did in alkane, and give it priority. In the sense, we are going to give it the least number on continuous carbon chain. And in alkane, we normally end with in. In alkyne, we're going to end with yin. Okay? So, like, the same method of naming is still the same method that applies here. Just that it's not the same family again. This is a family of yin. While the other one, previous one, was family of yin. So that's where the difference is. We still give the priority the way we give double bond priority. Okay, a compound can have both triple bond and double bond. And a compound can also have two triple bonds. So when we have two triple bonds, we call it 2 is diene and 3 is triene. Okay, and a compound can also have we have double bond and triple bond in the same compound. So all the things. Now, when you have double and triple bond, the one that is going to be a parent compound is going to be the triple bond. So it's going to have a higher priority. Okay. So if you look at the compound, the first compound have 2 triple bonds. And that's why we look at the position of this triple bond, their position 1 and position 3. We say 1,3 hexadiene, because hexa is because the carbon number is 6. Diene because it is 2 triple bonds. And this triple bond are position 1 and 3. I can also call it hexa 1,3 diene. Whether I call it hexa hyphen 1,3 diene or I call it 1,3 hexadiene, that's the same thing. Now the second compound, you can see we have double bond and we have triple bond. So whenever we are naming, we have to give the double bond, triple bond the priority, meaning that I'm going to start counting, giving the triple bond the least number. So triple bond will give me the guide on how to name. So that's why my triple bond is 1 yin. Then double bond becomes carbon number 4. While my methyl is carbon number 5. So these are the things. So when you're given a compound like that, don't name. Just make sure you separate all the carbons in their structural formula, making sure that where you have CH3 bracket 2 means that the first methyl is going to be a substituent, while the second one is going to be a terminal carbon. Because terminal double bond is going to have 2 position for attachment or hydrogen, 2 hydrogen. So these 2 hydrogen are replaced with methyl. Okay, why terminal alkyne is going to have just 1 hydrogen. So these are the things that will guide you. Whenever you're naming a compound, don't ever name them in their molecular form. Make sure you connect the carbon and hydrogen in their structural format so you can be able to know their exact position for appropriate naming. Okay, so now we can also use something like lines, okay, to represent this compound. So whenever you see a line, then the dot of that line signifying the position of carbon. So looking at the first, we have 1, 2, 3, 4, 5, 6, 7. So whenever you're using lines, the hydrogen is invisible. Okay, so we don't always put hydrogen. But if there's something like chlorine, only halogen or hydroxy group, you can indicate it. And we can also indicate methyl, the hydrogen is invisible. So that is how we represent compound using lines when I don't want to use color. But in the exam, if you're not conversant with that, please use the one you're conversant with. So you don't go and mess things up by trying to use lines. Because nobody will give you, I will tell you, use lines. No. So you can draw structure using lines, but it's not something you should mandate yourself over when you're not used to it, especially in the exam. Remember, in the exam, you're not impressing anybody. The most important thing for you to do things the way it should be done. Now, whenever there is methyl or substituent other than hydrogen, I will indicate it. You can see in that compound, the methyl has been indicated, while hydrogen remain invisible. So if it's hydroxy group, halogens or any carboxylic, this will be represented. But whenever there is hydrogen, it's always invisible. It's assumed, you know that whenever there is a line, if it's terminal, it's 3 hydrogen. If it's internal, it's 2 hydrogen. And when if there is double bond, we can also represent the double bond without indicating the position of hydrogen. Okay, so that's talking about naming whenever you want to draw your compounds using lines. So let's ask question before I bring the next slide you're going to talk about. I wanted to ask a question as regarding nomenclature. Every question you have concerning this, or people that we are not available in the previous classes, and you've gone through the slide and there are things you don't understand, let's talk about it now before we continue.
Hello, ma, I have a question.
Yes, sir.
Go ahead and ask your question. Let's
Hello,
do
ma.
one after the other.
I have a question.
Okay,
Yes,
go
before
ahead.
this slide, ma. The slide before this slide now.
Okay.
I noticed that the double bond and the triple bond are actually sharing the parent name.
This
before
particular one.
slide.
Okay,
No,
before
ma,
this.
the other one.
Okay, this one, okay.
Yes, I noticed that the double bond and the triple bond are sharing the parent name, eggs in
Yes.
one line.
Yes, because they are part of the compound. But both of them, they have hierarchy, right? Your name, whenever you want to call your name, you must involve your parent's name. Okay, so that is how it goes. They are 2, and they are both of them are functional group. In that functional group, we have hierarchy. So we cannot push out one. There's no how you talk about, because this hexene, this hex is part of the compound. The in is part of the compound. The yin is part of the compound. But the difference is that one is senior and one is junior. Okay? If I want to name it, I will talk about, okay, the junior will come first, and the senior, the baba of the compound is yin, because it is higher. The higher the functional group, the more priority it becomes. And that's the when it becomes yin is higher than in, I'm going to start naming from yin. But I will not say neglect in, because they are part of the compound. So when you like, just like talking about, I have a compound that have hydroxy group and I have carboxylic functional group. If I want to name that compound, I will say involve hydroxyl in part of the naming. Okay, so whenever you're naming a compound that has more than one functional group, the both functional group is part of the compound, but you're going to name them according to their priority.
My question is actually the double bond is part of the parent name. I was thinking I'm should be the parent name. Why the double bond should be a subsequent man?
Can double bond is not a substituent. So functional group is not a substituent. Please, there are 2 different things. Functional group is not a substituent. Functional group is not a substituent. Yeah. Double bond and triple bond, they cannot be substituted. They are never substituent. Substituent is something you attached on a carbon. Double bond is not a substituent. Now, if you come to alcohol, hydroxy group can serve as a substituent when there is another functional group like carboxylic. Because remember that hydroxy group is attached on carbon. It is not part of the compound. Double bond is like part of the compound. It's a hydrocarbon. It's hydrocarbon, so it's not attached on any carbon. It is on itself. It's part of the compound. That's what gives the compound the name it bears. So the compound, just like a woman that bears the father's name and the median name, a complex name. So that's the way it goes, because both of them are very important, are part of that woman's life. Are you still confused about that?
Thank you, ma'am.
So the double functional group is different from substituent. But there are some functional groups that can serve as substituents. And the most common one I know is hydroxy group. I don't like the noise in the class, so I don't like noise. I don't like noise, please. Lawal. Please, co-host, please control the class. Mute everybody. Anyone that is not talking should be muted. Lawal, mute yourself, or co-host, mute Lawal. Are you sure the course rep is in this class?
I'm here, ma. I'm here.
You're not mute
I'm here.
Lawal now. You're not doing the work you're supposed
Lawal.
to do. Mute them. You have the right to mute. I've made you a co-host. You have
I
the
can't
right
find
to
myself at
anybody.
home. Okay, I've seen
Because
it.
you're not, you can see you're not in this class. If
I'm
you're
in
the
the
class,
class, ma. I can see you.
how
I'm in
come
the
you
class.
did not see yourself as co-host?
Maybe when I went to use the toilet.
Okay, so any other question? I'm trying to download the other class we're supposed to have. No, my data is not connected. Ask your question on nomenclature. Ask question on your nomenclature. Oh, shit. Okay, no questions so far, right? We all understood nomenclature very well. That's good to know. Oh, so that not that when they give you one naming, say that they didn't teach you this. Ask question now. Some of you are in class, but you're not in class. That's the disadvantage of online class. People are doing what they're doing, and they're connected, so that they'll think they're in class. But they themselves know that they were not in class. It's well. Oh, let me open the other slide.
Hello, ma'am.
I can hear you.
Yes, ma'am. Please, I want to say, are there examples that we can be able to practice so that we can get used to? Because some of us, since we are not in chemistry line,
Yeah,
still
you're going to get the examples, because when we are going to fit in each of the compounds specifically, we should get examples, because this is like general introduction and nomenclature.
Okay.
So now the next thing we're going to talk about alkene. So when we talk about alkene, we're also going to do some naming on alkene. So from that, we are going to share some examples of practice examples that can guide you.
Okay.
My laptop is misbehaving, that's why. Okay, so any other questions so far? Now, like I said, whenever you have like hydroxy group and carboxylic functional group, now, are you on Google Classroom? Are we on Google Classroom?
No, ma, no.
Are you sure? I created Google Classroom for you guys. How come you say you're not on Google Classroom?
We are yet
Was
to
there
receive
no
the link.
assignment?
He promised. Yes, we are yet to receive that link, ma.
That's not possible. That's not possible. As I'm downloading the next class, I'm so surprised, because was there not supposed to be a class? Okay, you're very correct. You're very correct. You're very correct. You're very correct. Okay. I think I will do that after the class. I will do it. I've seen it. But I will not actually, because we're supposed to have our class work. Well, has there been any class work so far? Assignment so far?
We have one. You promised us to upgrade the assignment, then was to do it through that Google platform.
But you guys did not, you did not share that stuff with me. Did you upgrade it? Did you share it? Did you share with me the upgraded?
No, you said,
ma.
You said that as soon as the class is over, you are going to upgrade one of the questions. That has to do with molecular formula that you add to it. You add to it later, but you say you adjust the question before you give us the overall question for us to use for the assignment. That was what you said last class, last week.
Okay. Okay, I'm sorry about that. You would have reminded me now. There's so many things on this page like this. Cases like that, please do it to remind me.
Okay.
When I forget, just do it to remind me. Because I can easily assume that I've done it when I've not done it. Is anybody, can I send this slide on the, because I need to convert it with my system is not accepting anything. I didn't come with my laptop. I'm going to share this slide. Course rep, do you have your laptop there?
My laptop is off, ma. I'm just charging it. I'm using phone.
Oh, you're okay. You're not close to the laptop.
No, I'm not close to it.
Is anybody with laptop there that can do conversion for us?
Conversion from what format to what format?
You're going to convert to PDF.
Okay, to PDF.
Yes.
Okay.
PDF.
Okay.
Okay.
I'm
going
with it.
to share it now.
I'm with a laptop.
Rep, please share to your team now. Sharp. Share to the class. My laptop is misbehaving.
Ma, you said I should.
Check your WhatsApp. I don't know whether it's network or something.
Okay.
Check WhatsApp.
No, ma, it's not the network, ma. You are pausing your screen. That is why. If you check the icons of Zoom on your system, you will see pause.
No, I'm not using laptop for my Zoom.
Okay.
I'm using phone for my Zoom.
Yeah, you have paused the screen sharing. Maybe by mistake.
Yes. Just because I'm trying to share another file. So
Okay.
please, can you quickly convert that and send back to me to PDF? I don't know why this thing just now responding. Rep, have you shared with them? Oh.
They will receive it, ma. I want to share it. They will receive it. I'm sharing.
I just want somebody to convert it for me.
Okay, I'll share it to the platform now.
Please. I don't know why it's supposed to be able to convert to PDF. I don't know why it's not responding.
Anybody using laptop should please do that now.
Please, you guys should
Once you have converted it to PDF, please post to the group.
Yes, share the platform back. Oh shit. Any luck? Any luck? Just
I have
open
converted
file.
it.
Okay.
I've converted it. Is to find a way. Okay. Let me.
Okay. I've seen that. Somebody have done already. Thank you.
Okay.
Somebody have done it already. Thank you very much. Sure. Okay. Cost rep, can you share this as a co-host? Do you know how to share? If I can download this. It's supposed to be on my download. It's not sharing. It's not I can't send it to my email. Yeah, send it to my download it now. Come on.
Hello.
You know, you're always changing. How are you? Yeah, that's why I say you're always changing. So, good morning. Congratulations. So, what's your CGPA? This why? 219 is A now. But all of you had A. Everybody had A. Ah, this that lady was angry with me. That was actually guys mark. I wanted everybody to pass. You say you're busy touching the mark. You want them to pass, Abby? All of them had A now. What else do you want to see? So that's not released. It has been uploaded. You see it in your portal. See it in your portal. So no need of releasing. I think I'm trying to see if I want to see if I can request for rush it, whether they finish uploading. So just check your student portal and see if something is there. That's how it goes. So what's happening? Sorry, I'm in a class. I'm in a class. You're in. Sorry. I didn't even know that the speaker was on. What happened? So hello.
Amen.
Can we continue? Sorry.
Yes, ma'am.
I didn't know that
Well,
my mic was on. Okay, let's continue on alkanes. Like the general stuff, nomenclature. So we want to go specifically to each of the compounds. Alkane are saturated hydrocarbons, like we know. Okay, they are a family. So the least member of the family is when your carbon is 1. So that's what we call them methane. So they have a general molecular formula like we know, CnH2n plus 2. Okay, they are saturated hydrocarbons. So these are the structural formula. If you're taught to talk about structural formula, this is what you expected to do. You are going to tell us the linkage of all the atoms in the compound. So that's what made up the structural formula. Okay. So I will also just the second one we call it projection. So for your level, I'm not going to talk about projection. So just know we are talking about structural formula. Projection is another type of structural formula, but we're not talking about it. So we have partially condensed. You can see the difference between projection and partially condensed is that in projection, you're taking out the link of every atom. So whenever we're talking about structural formula, you're expected to use the projection. Although there are more details about projection, just use projection, where you're going to tell us the linkage of the atoms in the compound, how they are connected to each other. Then partially condensed is what we normally use whenever we are doing some naming. So because I'm not interested, what I need to know, which carbon is linked to what. So that's where we use partially condensed. Okay. And we have also stick formula. Difference between partially condensed and molecular formula is that in molecular formula, you tell us this is, I would write maybe C6. Okay, the way it is written on the first C4H10, that is the molecular formula. Okay, so I'm telling you the number of carbon and hydrogen. So I'm not going to separate them. So that's the molecular formula. So we have molecular, we have projection, partially condensed, and stick. Stick formula is when you're using lines to represent your carbon and substituents. And when there are substituents, you put them. So in this stick, if there is alcohol, I will put a connection where my alcohol is, and I put a functional group. Remember I said whenever you're using stick or line, you're not going to indicate the presence of hydrogen. Okay, that's stick formula. So alkanes, they have what we call isomerism. Isomerism, like I said is when the same molecular formula, a different structural formula. In alkane, the molecular starts from carbon number 4. Isomerism starts from carbon number 4. So carbon number 3 cannot have isomer. So whenever I give an example of isomerism, don't use anything, especially chain isomerism. You don't use anything propane. Okay. I can use propane for something like position isomerism. What I'll say, like propan 1 all and propan 2 all. Okay, but when I'm talking about chain isomerism, I cannot use propane. Okay, now in this butane, you can see we have normal butane and we have isobutane. Isobutane is 2-methyl propane. And remember that we cannot have any other thing other than 2-methyl propane. So in isomerism, butane is going to have 2 isomers. Now, if you look at them, from what you can see, their melting point changes. So the more the branching, the lower the melting point. Okay? And the lower the boiling point. Because when they are branched, they know that within themselves, they are generating heat, unlike straight chain. So that's why we have difference in their boiling point and melting point. In a straight chain, you can see that their boiling point is 0 degrees. While in branch one, we have -12, meaning that that one has a lower boiling point because of branching. Okay. So this is another one. This is normal pentane. While my isomer of butane is 2, my normal pentane cannot be 2 again, because the higher the number of carbons, the higher the isomers that you can obtain. So you can see we have 3 isomers for pentane, and the list continues. So these are the homologous series. Remember, homologous series is a family of alkane. This is a family of alkane, as you can see, from carbon number 1 to carbon number 10 as example, but it can be more than 10 too. Okay, but for your level, you are ending in 10. Then these alkanes can have like alkyl halide. Alkyl halide is also alkane, that one of the hydrogen has been replaced with halide. So this alkyl halide, just like alcohol, can be grouped into primary, secondary, and tertiary. In primary, in primary, the carbon that bears the halogen is going to have 2 hydrogen. While in secondary, the carbon that bears the halogen is going to have 1 hydrogen. In tertiary, the carbon that bears the halogen does not have any hydrogen. So that is how you know anything about primary, secondary, and tertiary, both in alcohol, in amine, in anything that are talking about primary. Go and look for the substituent. That's something that determines the compound being primary. It might be a substituent, like in this alkyl halide, we're talking about halogen. In alcohol, we are talking about hydroxyl. In amine, we are talking about nitrogen. So that nitrogen in amine, when it has 2 hydrogen, becomes primary. So when my halide, the carbon that bears the halide has 1 hydrogen, it becomes secondary. 2 hydrogen primary, no hydrogen tertiary. Now in alcohol, although we're going to talk about it when we get there, that is why tertiary alcohol does not oxidize, because there is no hydrogen in tertiary. Okay, so you should be able to know how to classify alkyl halide into primary, secondary, and tertiary. A compound can be given to you and said you should talk about the isomers. Okay, what are the likely isomerism that the compound can exhibit, and also classify them into primary, secondary, and tertiary. So you should be able to answer that question very well. Okay. Okay, physical properties of alkane. Alkane, because they are made up of carbon and hydrogen, they are non-polar. Okay, and because there is no presence of polar compound, they cannot undergo hydrogen bonding. They have weak intermolecular forces. Now, in terms of boiling point and melting point, they have lower melting and boiling point. And this melting point and boiling point can increase or decrease, well, can increase with sizes and decrease with branching. Now, the lower members, C1 to C4, are gases, while C5 to C17 are liquid. higher members are solid. Because they are non-polar, they cannot be soluble in water, but they can be soluble in organic solvent like alcohol. And that is why whenever they're preparing agbo, they use alcohol to prepare, because alcohol is going to extract both polar and non-polar. Okay, it's organic solvent. The water can only take out only polar components. So normally, if you're talking about agbo or your herbs, the most potent ones are the ones that have alcohol. And the best way to do this, you can also mix your alcohol and water so as to reduce the toxicity of the alcohol, okay, in terms of the hydration potential of alcohol. That's why it's always good for you to mix your alcohol with water, especially if your alcohol is concentrated. But alcohol components of agbo or your herbs are more potent because they have the capacity to extract more components, both polar and non-polar components. Okay, so these are the table telling us the
Let everything slide. Let it slide.
Hello, somebody is disturbing my class. Co-host, you're not doing your job. Co-host, you're not doing your job. People are disturbing my class. I'm not doing anything
I'm sorry,
about
ma.
it. Okay, the lower members are gases. You can see them. Methane. Methane is a gas. Okay. Okay, the lower members from methane, ethane, propane, and butane, they are all gases. The one we start from pentane, they are liquid. Okay, you can see in their boiling point. Okay, because gases does not boil because they're already in gaseous form. They can only evaporate. Okay, you can see branching. Look at my heptane. Look at my normal pentane is 36 boiling point and 130. The one will enter branching. That's my branching isopentane. You can see the boiling point reduces and the melting point reduces. So telling you that branching reduces boiling point and melting point. So if there's opportunity for OBJ and you're told which of the following will have the highest boiling point, go and look for the same molecular weight. The branching is going to have the lower one, while straight chain is going to have the higher ones, because branching reduces boiling point and melting point. How do we obtain these alkanes? We can obtain them from fossil fuels, which can be natural gas, petroleum, or coal gas. Okay, petroleum is a complex mixture of hydrocarbons. This petroleum, we have solvents there, we have fuels there, we also have raw materials for chemical synthesis. Some of the raw materials you can obtain from petroleum is your jelly. Your jelly is also obtained from your petroleum, lanolin, and some of those are obtained. So these fractions are separated from petroleum using fractional distillation. And this is what happens in our refineries, where they start fractionating the crude oil. They will start distilling the crude oil to obtain what we are looking for. From there, they are going to get natural gas. From there, they are going to get the fuel. From there, they are going to get some of the solvents. Even alkane is part of the solvent. It's part of the solvent that can be obtained using fractional distillation. So this is when are we supposed to end this class? Let me know. I don't want to encroach into class for time for another class. So whenever it's time for class, please let me know so I can summarize and we'll continue. Next time, at least, I will download all the classes so that we'll not have the break in transmission like we encountered today. Apologies for that. So these are alkane. We have from alkane the fractions. We can see gasoline, you can see kerosene, you can see diesel. So these are because they have difference in their boiling point. So the essence of fractional distillation is because of difference in boiling point. So when the boiling point of gasoline comes, all the gasoline in that crude will be extracted. And whenever we enter the next boiling point of kerosene, we remove it and put another vessel to collect kerosene. By this method, all the fractions will be separated from crude oil. So that's the method of separating crude oil from fractionating crude oil in our industries. So this is what happens in the refinery. You can see the vessel where the fractionation is taking place. Okay, these are the processes that occur. Okay, products from these fractional distillations are, as we can see natural gas, you can see your petroleum ether, which is a solvent used in the lab. You can see your gasoline, you can see your coke. Coke is a solid. Okay, you can also see your lube oil, you can see your gas oil, so the kerosene. So these are what we can obtain from petroleum. There are much more from this. Okay, so these are the components of your petroleum. So how do we synthesize this alkane? Alkane can be synthesized in large amounts. Anything you're talking about industry is always in large quantity. The essence is to optimize profits and minimize costs. So that's why lab stuff are purer than industrial. Okay, industrial has to do with mass production. So whenever you're doing in the lab, you're going to use small quantity because you want to obtain these compounds in a purest form before you then scale up in the industry. So that's why you can see small amounts. And the essence of lab is not for profit, is to obtain the reality before we go to industry and optimize. Okay, so in today's class, we are going to focus on lab. Okay, how do you obtain this alkane in the lab? This alkane is obtained in the lab using reduction of alkyl halide. Remember, reduction is simply addition of hydrogen or removal of oxygen. So this reduction process can be in form of hydrolysis of greener reagent or with active metal using an acid. Okay, these are the two methods we can obtain alkane using reduction of alkyl halide. Remember, alkyl halide is simply alkane that lost one hydrogen and it replaced with halide. So the same method. So we're going to reduce. Reduce is replacing that hydrogen that was lost, where reduction is addition of hydrogen. Using this method, that's just all we are doing, because we don't want it. We just want to remove what was lost using either hydrolysis or greener reagent. Remember, in hydrolysis, you have hydrogen and hydroxy group. So in that case, the hydrogen ion is what I'm going to obtain when I want to hydrolyze greener reagent. Okay, so and using active metal, I'm also looking for that hydrogen. All of them are by process called reduction. So in reduction of alkyl halide using greener reagent, you can see that greener reagent is RMGS. That R can be any alkyl. Okay, the essence is MgS, magnesium and halide. So when the first stage you are seeing here is that my alkyl halide is reacting with magnesium to form greener reagent. So this greener reagent is going to undergo hydrolysis to form alkane. Okay, so another method is just neglecting how greener reagent is formed and continuing in II, while my greener reagent is going to be hydrolyzed to form alkane. Remember, side product is not always necessary. So this is a typical example where my propyl bromide, okay, N is normal propyl bromide, because it's just like one propyl bromide or one bromopropane. So under magnesium, I'm trying to form greener reagent, which is M-propyl magnesium bromide. Then in the presence of hydrolysis, there's exchange of hydrogen and the MgBr to form my propane. So this is what we call reduction, addition of hydrogen. So that hydrogen has been added via hydrolysis of greener reagent. Second method is using active metal and an acid. Acid is like a catalyst that will help to release active metal from tin. So the metal is going to help hydrogen to be released from the acid. So now when metal comes, it's going to displace hydrogen from HCl to form tin chloride. Then the hydrogen is going to replace chlorine from alkyl halide. So with this method, I'm going to form my alkane without stress. So that's the two methods we are going to use for reactions to synthesize alkane in the lab. Remember, alkane are saturated hydrocarbon. Because they are saturated, they are not they are not reactive. Because when you're saturated, nothing moves you. So somebody like Dangote is financially saturated. You cannot just come and give Dangote, you want to bribe Dangote with 1 million naira. It's an insult. But just go and look for somebody on the street. With 500,000, the person can go and kill somebody. You can see. So that person is highly unsaturated. So when you want to bribe somebody that is saturated, you have to go and go extra mile, something that can attract that person. But when you see a hungry person on the street and just give the person one pack of food, the person can do wonders for you because the person is highly unsaturated. So because alkanes are saturated hydrocarbon, they are not reactive. You can see they cannot react with sulfuric acid, they cannot react with sodium hydroxide, they cannot react with sodium metal, they cannot react with all those. So they are typically unreactive. So what they do, the reaction they undergo is what we call halogenation reaction, combustion reaction, and pyrolysis. So typical reactions of alkane are halogenation reaction. In that halogenation, what they do is substitution reaction. I have a sim that had two sim space, and this sim has already MTN and Airtel in them. It's saturated. I cannot go and bring glue because there is no space. What I'm going to do is what they call SIM swap. I'm going to remove my Airtel. I say, okay, Airtel is disturbing me. Let me replace with glue. So that's what they call substitution reaction. I substitute my Airtel with glue. So that's the kind of reaction alkane undergo when you talk about halogenation. Another reaction it occur is combustion, when it's going to react with oxygen in air, burning in oxygen in air to form CO2 and water. Another reaction is going to undergo is pyrolysis, which is cracking higher molecular alkane forming lower ones. So these are the reactions that we can see when you're talking about alkanes. So under halogenation, we are just removing. Remember, we remove, just like it was halogenation reaction that formed alkyl halide, and the reduction that also formed the alkane. So in halogenation, we are forming alkyl halide. Okay, we are removing one hydrogen and replacing with what? Any of the halogens. It can be bromo, it can be chloro, it can be iodo. Fluoro is not always used, okay, because it's very, very corrosive and very highly reactive. So we only use chlorine, bromine mainly, and iodine. Somebody is disturbing my class. So for this to occur, we need heat or light. Either heat or light. The light can be UV light. So these are something that occurs spontaneously. Cos rep is not doing its work. It occurs spontaneously. Where this because it yes, I've seen that. Thank you. Halogens are supposed to be in the presence of heat or light. We're going to form a radical, okay, which is going to do the substitution reaction. So I think that if the slide is not there, it means that we don't want to push you into the mechanism of this halogenation reaction. And if you want to understand the mechanism, you can also, when you want to, anything you want to know in details, go to my YouTube channel, Dr. Anita came. There's a place for nomenclature, there's a place for arcane, where you're going to see every details you want to know about it. Because at this level, we are meant to teach you the basis of basic organic chemistry. So going into details is going to destabilize meaning. So that's why we kept it very elementary. So if you want to know more details about alkane or some of the topics treated, go to my YouTube channel. You're going to see them treated in details. We are going to remain elementary here. So in terms of the reaction, chlorine and bromine is always used. Like I can see, iodine is never used in halogenation reaction. Okay, chlorine and bromine is, and fluorine can never be used because that one is highly very reactive. So in terms of high elimination reaction, tertiary is better than secondary, and that secondary is better than primary and methyl. Okay, bromine is more selective. Chlorine is always used, more used. Okay, in this reaction. Okay, combustion reaction, like I said, is when alkane is going to burn in oxygen or flame, and we are going to form CO2 and water. While pyrolysis is when higher alkane under high temperature is going to form smaller ones. So these are typical reactions of alkane. In this example of halogenation reaction, you can see my chlorine under HV. HV is UV light. Okay, so this cannot occur without that UV light or heat. So whenever you're writing such reaction, either you put heat or you put HV, which is light. So these are the halogenation reactions. So we'll give you an example. Okay, so whenever we have there is a tendency that we can have something like more than one. Okay, when you have more than one, you're talking about one is primary, one is secondary. So in the exam, nobody will penalize you if you give us just one. Okay, so don't bother. Some of these things are what happen in the lab. The percentages you're seeing are what is obtainable by experiment. So it's not something you have to cram. By experiment, after the synthesis, realize that the tertiary has higher percentage than the primary. So this is what was observed in the lab. Okay. So we also have what we call cycloalkanes. Cycloalkanes is when my alkane are in a ring form. Like when I have ring 3, we call it cyclopropane. Ring 4 is cyclobutane. Ring 7 is cyclohexane. So the same number of carbon, but because they are in ring form, we call them cyclo. We use the word cyclo before naming them. So we have also cyclo. You can look at their cyclos. You can see cyclopropane, butane, pentane, heptane, and hexane. So these are the cyclo counterparts of my alkane. So alkane can have aliphatic and can have cyclo. Okay, aliphatic is a straight chain. Then we have cyclo compound. Okay, any question on alkane? Any question on alkane? I want to create the Google platform so that you can then all the questions will be updated, and you go ahead and keep yourself busy with plenty of questions. I'm also going to share going to practice. If there's no question, or move, tell me there's no question, so we can move ahead. Okay, we assume that there's a question, right? Okay, I'm going to link for with you to connect the next class, and when you're done, you're going to share them on all my assignment classwork will be on Google Classroom. So you go and share them on Google Classroom. So I'm creating the Google Classroom now. AC 821 and 921. 921. Okay. Okay.
Hello, ma'am.
Can
I ask my question now?
Of course, now I've been saying people should ask questions. You know, I'll go ahead and ask.
Sorry, ma, my network was bad. All right. So, ma, I want to ask
Ask
question
your
on
question.
classification of. Okay, ma, I want to ask question on
Hello.
classification of hydrogen. Ma, can you hear me?
Who is asking
Hello?
question?
Hello,
Ask
can
your
you hear
question.
me?
I can hear you very well.
Okay. Okay, ma. Ma, under classification of hydrogen halide, where you mentioned primary, secondary, tertiary, I didn't really understand how you were able to differentiate the primary, secondary, tertiary. I'm sorry, my network was shaking at that point, so I didn't get it.
Okay. Now, let's go back to the slide. Now, whenever you see a compound, okay, for you to know whether it's primary, remember we're talking about alkyl halide. So look at the carbon that bears the halide. That carbon will tell me whether my alkyl halide is primary, secondary, or tertiary. If my alkyl halide, if the carbon that bears the halide has 2 hydrogen, look at the first one, we said primary bromide. You can see that the carbon that bears the bromine is the terminal carbon, having 2 hydrogen, right? Then look at the second one we call secondary bromide. Look at the carbon that bears the bromine is having 1 hydrogen. Look at the tertiary chloride. The carbon that bears the chlorine is having no hydrogen. So that's how to know primary, secondary, and tertiary. In primary, the carbon that bears the halide is going to have 2 hydrogen. Secondary, the carbon is going to have 1 hydrogen. Tertiary, the carbon is going to have no hydrogen. Is that clear?
Yes, ma. Thank you so much, ma. Thank you.
Yeah. So this same thing applies for alcohol. If you come to alcohol, primary alcohol, the carbon that bears the hydroxy group is going to have 2 hydrogen. Secondly, the carbon that bears the hydroxy group will have 1 hydrogen. Tertiary, no hydrogen. So anything primary, secondary, and tertiary, anywhere in the world, follow this. Okay. So having said
Yes,
that,
ma.
chloro or halomethane, halomethane is not a primary, it's not secondary, it's not tertiary. Because if you look at the methane, halomethane, like bromomethane, is going to have 3 hydrogen, which means it is not primary. Okay. All right. Any other question? I think I've shared the link of Google Classroom in your general platform. Any other question before we end the class for today? Any question again? So many people are not in classroom in class today. Course rep, attendance, please. I want to know people so that when the time comes, I will see people that are messing up in their exam. I will know. I will take to the attendance. Please, I need this attendance. And course rep, I want you to go a step further. Is screenshot this assignment, then go and have your Google sheet where you're going to be telling me the details of the classes and the attendance. I want to know people that are coming to class and people that are not coming to class. I need it because of time for exam. Okay. Thank you very much. So I'll see you guys in the next class, and I'm going to share the slide for the next class so that you will not be stranded like the way we are today. Apologies for everything. So thank you very much and enjoy your day. So connect to the Google Classroom. I'm going to share the question. But please share the questions, the one I shared. Despite the one I'm going to say, I'm going to upgrade. Share the good question to me on my private page so I can edit and share in the Google Classroom. And I'm also going to add to the questions because you're going to have enough questions to solve this weekend. Thank you.
Okay.
All right, bye for now.
Thank you, ma'am. Yeah, bye for now.
Bye.
Thank you, ma'am.